Welcome to part 2 of building a web application with Retrieval Augmented Generation and ChatGPT. So, in the last video, we templated out the app.py here along with our various routes. And we were able to successfully get an upload. Now we are going to go ahead and start working on the actual RAG class. And I'm going to create a new file and call it rag chatgpt.py. And we will call it rag model. So class rag model. And the first thing we're going to need to do in general, so we are going to need to go through a tokenization process. So RAG uses a process called semantic search, and what that's going to do is we're going to basically build up data. We're going to embed that data, so convert it to numbers basically, and then we're going to use a semantic search to take that data and do a search on it mathematically. So semantic search gives you the ability not just to do a SQL query or a text search, but to actually take two sentences, convert them to a vector, and then compare how close those two vectors are from a meaning perspective. So, if we're talking about a question something like how fast can a Ferrari go, and then the top speed of a let's say, what is the top speed of a sports car? And you don't have to type this out, I'm just throwing some strings in here for comparison. So if you were comparing, trying to do a search to find this, using this, and just doing a keyword search, Ferrari isn't going to pick anything up in this sentence. Fast isn't going to pick anything up because here we used the word speed. But a semantic search is going to actually convert these two into a vector in our embeddings, and it's going to let you do a search that, a data search that will pull related sentences, related content, regardless of whether or not those things have a direct keyword match. So why are we doing this? Well, as we covered in the last video, the point of retrieval augmented generation is, and it's a very, very simple concept. We're going to do a search among, some collection of data, and we're going to find related content and pass that content along to the LLM in our query. So if we're looking for medical information, we're going to go search our human nutrition text here and find related things, and then bundle up that content and send it along to our LLM, which can then use it as context to answer the question, and thus be either less wrong because it has data and context that it didn't have before, and you're now checking it against facts, or potentially even give you answers to things that it would have no way to know. Again, like your internal company data. So the first thing we're going to do here is we'll go ahead and define our init method, and we'll say file upload dir equals uploads. We'll need that later. We're going to need a quantization config. And actually, no, we won't. That was for the version of this that works with a local LLM, which we're not going to be doing. So let's go ahead and set our file uploader. And we'll make that file uploader. We'll go ahead and say self.embeddings equals none. We'll set a device. So I have a GPU. If you don't, this will return CPU. Self.device equals CUDA 0. If torch dot, and here we need to go ahead and import torch. So if torch dot CUDA dot is available, else CPU, and then we'll go ahead and print loaded model on self.device. All right, before we go any further, let's just go ahead and run that and make sure it's working. So I'll do this right up here. We'll go ahead and import from RAG ChatGPT, import RAG model. And then down here, we'll do model equals RAG model, and we do not have to pass in any parameters there. So we'll just run this, make sure that our initial code here checks out. And hey, loaded model on CUDA 0. So we are successfully on the GPU. If this has CPU for you, one, make sure you actually have a GPU in your machine. I'm assuming you know if you do. And then also make sure that you have the correct index URL for Torch available on the Torch website. All right. So let's come back over here to RAG ChatGPT. We will need to load NLP. Let's see. So we're going to pull from Spacey. So from spacey.lang.en, import English. All right, and then we can go ahead and self.nlp equals English, and self.nlp.add pipe sententizer. All right. Let's go ahead and do our load embeddings model, or our load embeddings method. Used the word model too much recently. Embeddings. Actually, we'll do a pass on this one. We won't have the data yet, so let's go ahead and start with process file. So what we're going to end up with is we're going to end up with a process files method that will loop over all the files in uploads, and for each file it's going to call process file on it. So let's go ahead and just get process files in place. That'll make things a little bit easier. So text.df equals pd.dataframe, and we'll go up to the top. And go ahead and import pandas as PD. All right, and then for file, we'll need, let's see. We will also need to go ahead and import OS. And so for file in os.listdir, self.fileUploadDir. All right, and it doesn't have it because I did not pass in self. And I need to do that for all three of these. Okay. Why? For file in os.lister. That in is important. So we're going to say print processing file df equals self.processFile file name equals file. Print. We'll go ahead and just print out file df. And then we'll do text df equals pd.concat, and then text df file df. So basically what we're doing here, we're looping over everything in self.fileUploadDir, which right now is one thing. And then for each file in fileUploadDir, we are returning, calling self.processFile on it. We are printing the results, and which should just pull the head of the data. And then we are using pd.concat to concatenate this blank frame, data frame, and slowly build up a data frame of all of our data. So finally, we can go ahead and say embeddings df save path is, let's see, text chunks and embeddings .df.csv. Actually, let's just go ahead and make this part of our init method, self dot, and then we don't need it here. We'll be using that in a few other places. So text df.toCSV, self.embeddings df save path, and index equals false. So why are we saving it to file? So there are a couple different ways we could do this. We could process files on boot. We could, and basically just process the files every single time the app starts, and pull that data every time. But it can start to be a slow process as you have, multiple files. So what we're doing is we're processing. We are saving that to CSV, saving our completed embeddings. And then later on, we will have a load method here that's going to pull those things in when they're needed. All right, so let's come up here and do process file. And this will be a little bit of a longer method. So we'll have file name, min token length. So, if we end up with, shorter tokens, say, 10 characters, that might not actually be very useful. You might catch the end of a sentence or something, and we just don't care about that data. All right, we'll also do num sentence chunk size, and we'll set that to 10. And something I said in the first video is that this is really intended to be a bolt-on to another series. So, if some of what I'm typing through doesn't make a lot of sense, that's fine. I do recommend going back to the video that I linked in the first lesson here, and going through that at some point for sort of the full context on what we're doing. So, for our process file, we're going to do file path equals os.path.join self.fileUploadDir and file name, pages and text equals self, and we are going to need a method called open and read PDF. So I'm going to go ahead and PDF path equals file path. All right, and let's go ahead and code that out while we're here. So def open and read PDF self PDF path str, and then it's going to return a list of dictionary. All right, and for this we'll need fits. So let's go to the top and import fits. Okay. All right, so here we're going to do doc equals fits dot open PDF path, and we will do pages and text equals a blank list there. So for page number, page in TQ, let's go ahead and get our TQDM imported. And actually, I think, yeah, there's a special, it's not just import TQDM. If you just import TQDM, it will, the import will work, but then it'll fail later on with a, unable to serialize object error. So from TQDM, import TQDM. All right. Coming back down here to our open and read PDF. So we will have for page number page in TQDM dot enumerate and doc text equals page dot get text, and I'm just going to add a to-do here. Add text formatter. Okay. And then we'll do pages and text.append. And then this is where we start to build up a little bit of data. So we'll go ahead and do page number, page char count is the length of text. Page word count is the length of text.split. Page token count and we're starting with a rough token count here. We'll get a little bit more specific later, but for now we're going to say each token is 4 units, and we will do length of text divided by 4. And then finally the actual text. Okay, and then we'll return pages and text. Okay, so we've got our open and read PDF. We've got our, we can come back down here now and continue with our process file doc. And now that we've got pages and text, it's probably a good, well, no, let's get far enough down to where we can at least convert it to a data frame so the code will run all the way through. I would like to see this run earlier in the process, but we do need to go far enough that it actually will run. So let's do so this is where we're going to start building a little bit more statistics around, the number of sentences, the page count, number of sentence chunks, some of those things. So for item in TQDM, pages and text, item sentences equals list self.nlp item text dot sentence ts. All right, and that self.nlp, so remember that is calling the spacey sentence-sizer that we added here. So we pulled in spacey English. We added a sentence-sizer pipe to our English NLP here, and we're using that here to generate our sentences. Okay. We want to make sure that all of our sentences are strings. So we're going to do item sentences equals str sentence for sentence in item sentences. Okay. We're going to do page sentence count spacey, and we won't use all of this data later, but I am going to leave it in there because you can play around with it and use it for other things. So we're going to keep all of the data that I've got built up. So here we will do page sentence count spacey. We'll do item sentences. Okay. We'll do item sentence chunks is equal to self dot. Let's see. I think we're going to need a new function for this as well. We're going to need a split list. So let's go ahead and do that. So def split list self input list and that will be a list of strings. Slice size is int equals 10. Now I've got okay, and then we're just going to return input list I plus slice size for I in range 0 length of input list and slice size. So we're basically just taking our list and breaking it into sentence chunks. So specific sizes of chunks that we can then search later on. Okay. All right. So here we're going to say self.splitlist. Self.split list. Input list is item sentences. And slice size equals num sentence chunk size. All right, and then item will collect our num chunks. Equal length item sentence chunks. Okay, and then we'll just go ahead and turn it into a data frame. df equals pd.dataframe, pages and text, df.head. All right, and let's see if up to this point we can successfully, I'm sure it'll error a little bit later, but let's see if we can get some data from this. So if we come back here to app.py and we want this update file post to return something, So actually, it's not going to be upload file. It's going to be the file processing. So right now, this is one of our to-dos. Okay. And what we want to do here is we want to call model.process files. And we should not need to add anything extra there. So, all right, let's go ahead and run our app. And I will pull up our simple chat. And we need to do /admin here. And process files. And it should error. Well, we told it to always return file processed successfully, so it is not going to error. But what it did do is it gave us some of our data here. So you can see we've got it didn't display it very well. This does display a lot better in something like Jupyter, but we can at least see that we're starting to get our page number, num chunks, some of the data that we're trying to embed here. Let's go ahead and do df sentence chunks. Let's see if that'll work. Okay, there we go. Just wanted to make sure some of that data was making it in. So you can see here, we've broken our document into a series of sentence chunks, and it is able to go and pull that information and print them out. So we've gotten that far. That is working, and that is exactly what we want. So let's move on to the next step here. And there is a decent bit more data processing to do. But I think you can start to see what we're doing. We're building up data, data about our data, metadata, on our, on our process here. So we're going to go ahead and do another pages and chunks. Or sorry, not another. We're doing a pages and chunks as opposed to a pages and text. And that will be blank for now. And for item in TQDM pages and text. Oh, and something that threw me the first time I saw this code. So, we're not explicitly going back to pages and text here. These items, the item here is a reference. It's a pointer, effectively, to an item in TQDM. So as we modify the item in this loop, we're never having to explicitly put it back in pages.txt. This is effectively live editing the items in the pages and text list there. So we'll do for item in TQDM pages and text, for sentence chunk in item sentence chunks. We'll create a chunk dict equal to a blank dictionary. Chunk dict page number equals item page number. Let's see. We're going to do chunk dict source file. And we're doing this for the functionality that you saw earlier, where it shows the page number and the file that each thing was pulled from. So this will just be file name for each one. Obviously, we're duplicating data, but it's the easiest way I found to just hang on to that data throughout the process as it's connected to the sentence chunks. So join sentence chunk, join sentence chunk. And what we're doing here is we are replacing anything with a double space with just a single space, and then stripping surrounding spaces. And then we're doing a bit of regex to clean the data up. So join sentence chunk equals, and we will need to import RE here. So let's just go to the top, and we're going to import RE. Okay. So down here, that is not what I was looking for. All right. Join sentence chunk equals re.sub. And A to Z. Okay, join sentence chunk. We'll go ahead and say in our chunk dict with our sentence chunk, we are going to have a joined sentence chunk. Chunk dict chunk char count is len of joined sentence chunk. Chunk dict chunk word count is len word for word in join sentence chunk.split. So we're basically just putting together, oh, and I need an extra set of parens around that. So we're basically just grabbing a word count based on the number of spaces. That's probably not perfect, but it's close enough. And then chunk dict chunk token count is equal to the length of joined sentence chunk divided by 4, and pages and chunks dot append chunk dict. All right, so we now have a pages. We went from a file, which we loaded, to a pages and text, which has all of our pages and text, and then we reprocessed that into a pages and chunks. And actually, we did not end up using that data frame after printing out the initial data. But so we now have a pages and chunks with a lot of the same information, but now split into chunks successfully. So now we can go ahead and say we are going to turn that into a data frame for pages and chunks. We're going to go ahead and cut those out that are over our min token length, or under our min token length. And chunks over min token len equals df, where chunk token count is greater than min token length. And then we're going to send that to a dictionary. Orient equals records. Okay. And then we will go ahead and we don't have an embedding model yet. So we're going to add a to-do here. To-do call self embedding model. Okay. And then really that was going to be the last step. So let's go get our embedding model set up. Or at least the last step in that method. So our embedding model is going to use the sentence transformer. So up here, we're going to go from sentence transformers, import util and sentence transformer. Yep, we've got a few different to-dos in here. Okay, so now up in our init method, we're going to have self.embedding model is equal to sentence transformer, model name or path, and we're going to use all mp-init, base v2, and device will be self.device. Okay. And then down here, again, back in our process file, we're going to go ahead and call our embedding model. So for item, again, in TQDM, pages and chunks over min token length, we're going to do item embedding equals self.embeddingModel.encode. So this is where we'll actually take your text data and turn it into embedded numbers that we can then semantically search. And we will be sentence chunks. Let's see. Let me make sure I'm doing that correctly. So that actually needs to be sentence chunk because that needs to line up with this. And then, so basically what we're going to end up with is we're going to end up with a data frame that has all of this data, but also contains an embedded version of the sentence chunks in embedding. And then finally, we will do text chunks and embeddings df pd.dataframe, pages and chunks over min token length, and then return text chunks and embeddings df. Okay, so that is the entire process file function, and assuming I didn't make any mistakes there, we should now be able to call, I'm going to delete this because there's nothing in it, but we should now be able to go to our app and call our process files, and we should see it doing exactly what it's doing. So it is processing human nutrition text.pdf. And you know what? We did not give ourselves any output, any completion output. So I'm going to go ahead and in the process file method, we're just going to throw in print info completed loading file name. It is kind of implied, but I do want to have that in there. So now I'm running process files, and we are successfully processing our file, and we should get a nice little message at the end. Oh, still not, here we go. Completed loading human nutrition text.pdf. All right, this video is getting a little long, so this feels like a really good place to go ahead and stop for now. In the next video, we'll go ahead and get into the load embeddings. We'll add our text formatter, and then we'll start working on the section that actually calls ChatGPT and passes some of this data along with it. So with that, I will see you in the next video.